We've established two main formulas for position, velocity, acceleration, and time. Got this guy here, which is so important, it's been renamed the first kinematics equation, and that's where the quantities given and to find are v initial, v final, time, and acceleration. Then we just came up with the second one, and we use this where the quantities given and to find are v initial, v final, t, and delta x. Okay? First one was a, now we have delta x. The first formula was derived by rearranging the definition of acceleration. The second formula was found by examining the velocity time graph. Since both of these formulas are true, we can combine them and we'll find another one. And what we're going to say is Vf is equal to Vi plus At. That's the first formula. If we see Vf in another formula, I'll give you a clue, here it is, we can replace it with Vi plus At. So we take this here and replace Vf with that term. So let's start. Here's our one formula that we just derived. And we want to get rid of the brackets because we're going to be doing some algebra here. So we distribute the 1/2. And we get 1/2 VIT plus 1/2 V final t. What do we do next? We take this guy, who's VF, and replace this VF with him. And that's what you see over here. So the VIT, 1/2 VIT carries down, and then we have 1/2 times parentheses VI plus AT times t. Now we're going to get rid of the parentheses again by multiplying through by t. So this first term comes down undisturbed, and then we're going to have 1/2 times Vi times t for the first term, then 1/2 times At times t, and what's that going to be? Well, t times t is t squared, so we have 1/2 At squared. Do these two guys look familiar? Yeah, they're both VIT, so let's just add them up. So 1/2 VIT plus another 1/2 VIT gives a whole VIT. So we have displacement is VIT plus 1/2 At squared. This formula is so important that it has a special name, the second kinematics equation. So we now have two kinematics equations. We use this formula with acceleration, time, and the initial velocity to calculate the displacement. Let's go a little further by substituting delta x, or the displacement, which is x final minus x initial, because we're going to find the formula that is more commonly found in textbooks and on the web. So here's what we just found. We substitute in x final minus x initial for delta x, and then we just put x initial on the other side by adding it to both sides, and we get this. There's our second kinematics equation, as you'll find on the web and in textbooks. There's also a third kinematics equation, but we'll save that for our next course.